Hey guys, I'm going to do a quick video on factor strings and prime factorization. That's what we did today. It's 1.9. And really, when we talk about factor strings, what we said was it's nothing more than renaming a number, a target number. It's a string and number that renames a target number. Okay, so we actually in class we started with the number 12. Just to recap, the number 12. To rename the number 12, there's lots of different names we can put together, but in terms of our factor strings, we're going to stick with multiplication because we're working with factors. And I'm looking for strings of numbers to put together to equal 12. So a short string, a two-number string, would be something like 3 times 4. That's a string. That right there is a string. It's only 2 numbers long. I can think of another two-number string, 6 times 2. That's 2 numbers long, but it is a string that renames the number 12. And so we took our two-number strings, and I asked the question of, can we turn a two-number string into a three-number string? And we realized we can, because we can take a two-number string like this, 3 times 4, and we can say, we can take the 4 and we can say that 4 is really a 2 times 2 in disguise. So I can take that original two-number string and transform it into 3 times 2 times 2, because that's really our hidden 4 right there. And then we did the same with this one here, and we realized, okay, we take that 6 and we can break that down into a 2 times 3, again times 2. And actually what you notice is that they're the same. They're in order, but they're the same, and that's because this string is the longest string we could possibly put together. It's made of all prime numbers. This is prime, this is prime, this is prime. And because it's a string made of all prime numbers, we call that string the prime factorization. It's the prime factorization for our target number of 12. And that's special to the number 12. It's like a fingerprint. Okay? We went through and we found other strings for other numbers. And I showed you kind of a shortcut way, which is really the same thing of breaking down numbers, but I showed you this to find the prime factorization. I showed you that factor tree. So for example, we take the number 40. We're going to start just as we did up here, but we're going to start with two numbers that multiply to get the number 40. And you can pick any ones you want. So I'm going to start with 4 and 10, and they came from 40, so I'm going to draw some branches to show that. And I can break each of these down further and further, trying to stretch out my string. So 4, really that's a 2 times 2 in disguise. And a 10, that's really a 2 times 5 in disguise. And if I look again, I can't break these down any further because they're prime numbers. And so this is my prime factorization, my fingerprint for the number 40. Another way to write this is with an exponent. So I can say I see some 2's on my list, and I see 1, 2, 3 of them. Exponent of 3 times 5. And that's it. Prime factorization and factor strings.